Thanks everybody for coming out today for my first ever presentation at Text Analytics. So I appreciate everybody's attendance today. And the theme of my short talk today is the frontiers of named entity extraction. And thanks to my wife, I'm not arriving before you in a cowboy hat. But the thought is that we can take a survey of what it looks like to do named entity recognition and extraction and disambiguation currently, and understand the limits of the technologies as they exist now, so that people can hopefully be able to speak intelligently about the industry, maybe come up with a few great questions to ask people who have solutions that they want to provide to do this task, and also to get an idea about all the fun things that really smart people have been throwing at this problem, and understanding the ways they can fit together and the maybe creative ways there might be room to improve these models in the future. So to introduce myself, I'm Brian Goss. I'm a taxonomist. I also do text analytics. With EBSCO, I do not have a background in computational linguistics. I don't even have a background in linguistics. I have a Juris Doctorate degree. So if everybody needs legal advice, this is not legal advice. So I started in legal research, moved my way to legal taxonomy, and that was my gateway drug to taxonomies generally, ontologies, and now working on text analytics. And I can save you guys a little money from any potential legal education that you might want to pursue. One of the first things you'll learn is that if you're in the courtroom or if you're trying to interview a witness, the rule number one is never ask a question you don't know the answer to, because you don't want to look so like that in front of a jury. But I'm going to break all those rules today, because this presentation will have all kinds of questions and ideas that we don't know the answer to just yet. So don't tell my legal professors. But the frontier frame is the one that I'll be coming back to in the presentation, and that's just to, like it says, to highlight where the boundaries are, to show where the limits of each approach are. As I've said before, there's great approaches, but each one has maybe a blind spot or doesn't have the full capability to capture everything we may want from these processes. But since it's a frontier where geographical frontiers where things are messy, people are meeting for the first time, different cultures and languages are all talking to each other. Like a frontier in this sense is messy, and there's lots of great ideas out there working with and together, collaborating with each other to further the state of the art. To that end, what is named entity recognition? If you take a sentence with the opposite of the stop words that we had in a presentation just before here, the ones we'd want to pick out that describe the formal proper names for people, places, organizations, even titles of works of art or media, dates, times. We want to pull out those discrete elements so that we can flag them for users or match them up to items we already have, so that somebody who's interested in one of those entities could use it as a jumping off point to pull in more information. And the two elements that I see of named entity recognition, and in the scholarly work that I've seen, recognition stops maybe sometimes at phase one, but for lots of our uses, I still think phase two is incredibly important, which is to take a recognized entity and match it. But between these two phases, the first one is just to be able to spot it in the text. So there's processing methods that lots of folks have used for concept or other extraction methods. We've got rules, we've got statistical models, we've got natural language processing. We're going to cover some of the examples of both of those. And then we're going to come back to see, once we've located something in text that we are confident is a personal name, what do we do with it? How do we make sure that we are linking that to some core concept? How are we making sure that we're covering every synonym we could imagine for a company, for example, or a person's nickname, or all other kind of data that might be in our systems? How do we handle when the recognition was confident but made a mistake? What do we do when we have words with multiple meanings? Polysemy or homophones or homonyms. Of course, there's multiple words for words that have multiple meanings. I always think that's great. Those are some of the barriers to getting the second phase to work. The first phase, again, is where we're trying to pick out the text from the text, the kind of entities that we're interested in. Rule-based approaches, in a general way, we have direct control. We can make a discrete rule that captures exactly what we want. We can implement it quickly if we can write it quickly. But we need manual rule writing to capture all those. If we have 400 companies, we might be able to imagine a project, but 40,000 companies, we'd have to devote a lot of work to creating a rule manually. And once we've created that list, there's a brittleness involved in having variations that won't match the rules we've already created. So it's not going to be able to adapt as much to text in the wild. And for examples, we've seen them probably throughout our text analytics conferences, but straight string matching, searching Twitter, searching just based on a keyword, that's the in and out of rule-based approach. Statistical approaches, you can have great adaptability and you can get effective results without this much work in the beginning, but you have a computer that requires a lot of intense work. You need programming, you need statistical knowledge, you need labeled data, which can be a major stumbling block for entities that you may come across just a few times. So your training set needs to be large enough to give the computer a chance to apply its statistical analysis. And once you've got the rules, they're complex. And if you need to go in and change something, if you are noticing bad behavior in its usage, you're going to have to go in and take your mind to where the computer has gone, to take your mind to where the statistical weighting has gone, and that's much more complex than the rules-based. So I'll go through a few. I'm a lawyer. I'm not a programmer. I am not even a statistician. I'm thankful that I've been invited to talk to you guys. But I know a little about the different models, the general models used by themselves or together in lots of products. Some of the first ones, support vector machine and naive Bayes classifiers. We're taking words as data points. For SVM, as it's known, you're mapping the data points and then finding, in a 2D map, you draw a line that would take the labeled data that you're trying to send to the system, make a line that will split them as efficiently as possible. Except this is potentially infinitely dimensional, and so that line becomes a hyperplane, and that's as far as I know about that. By the classification using naive Bayes classifiers, that's been a common approach for many decades. The issue with these two, though, is that, and with other models, is that there's a tendency to take amongst the ones that you are evaluating to overfit the training data that you've got already. You can do a great job getting perfect recall and precision from your training data, but once it's put out into maybe a live environment, you've gone too far past maybe its most maximum efficiency for your product. Plus, it's computationally intensive and has the same drawbacks as some of the statistical models that I brought up before. Hidden Markov models, conditional random field, these are some things that take in the sequence of the words in the text that you're trying to look at. They're trying to take the sequence to find probability that the next word is the one you're interested in. You're also taking in the maximum entropy hidden Markov models some features of the text beyond just the words, like is it in the title, is it in the first few sentences, or the heading section, if you have structured data like that. There is conditional random field is one we've seen in some of the public-facing named entity recognition systems, and it improves a little on the Markov models, and it's one that's used in, like I said, a few approaches, but like the first two we saw, these require a lot of computation, require a lot of programming, and there's some bias involved in Markov models. You get a push early on that might hide later values in the text that that would be helpful to pull out. We've got other ideas that we've put towards named entity recognition, like part of speech. We've talked a little bit about that in other talks today and yesterday. So we can distinguish which ones are proper nouns. It's a great place to start. But knowing that something is a proper noun is only half the battle. Once we need some other layer to have some more of an understanding about whether or not this is a person, place, or thing. There's some orthographic, maybe I'd just call these linguistic approaches with a fun name, n-grams. Those are taking not just a one word, which would be a unigram, but a pair of words, a triplet of words, and beyond that to take a windowed look at the text, and from that try to use that as the basis for the confidence you have that this set of words feels the named entity that you're looking for. TF-IDF, term frequency, inverse document frequency, is a good way to boost words that are rare in your text, and this is important for named entity recognition because you'll likely see it referenced maybe once or twice, or the person's name is referenced once or twice, and you'll have to, especially with words that have ambiguous meanings or are connected to nouns that may not be the ones you're trying to extract, rarity is a good way to capture that element, but it assumes in the first case that your nearby words give you all the meaning that you ever needed to figure out whether or not this was a named entity that you want to extract, and we know that's not the case. And for TF-IDF, you get a score for rarity, but you don't understand whether or not that rare word is actually one that makes sense for your classification. More linguistic ones like skipgram and continuous bag of words, these are two sides of one coin. The skipgram method is taking a word and using your computer to find out what are the most likely context words that you'll find around it. Likewise, with continuous bag of words, it's the opposite. So you've got context, a paragraph with a missing hole in the middle, and you want to guess which word is there in the middle. Then between these two, the main issue is that words with multiple meanings, since each word is included in your system once, there's blindness to it, and you get in trouble with words that should have different context rules or should lead to different context rules. And at the end of the day, likely the most popular word is the one that is chosen with these systems. Syntax is another one. You can get a great head start by understanding subject-object syntax in your sentences, but just like part of speech, it requires proper grammar. Maybe that's good if you're using scholarly articles. Not probably as useful if you've got Twitter as maybe the database that you're looking at. And it gets you a guide as much as part of speech does. It's a shallow guide. You can find the nouns, but sometimes that's the starting point for further analysis. Word clustering, it's a bit like some of the ones I talked about at the very beginning. You're mapping, again, the text, and you're trying to map it so that you can divide things into multiple clusters, not just one line. And a problem that a frontier of word clustering is that each word in its most basic form arrives only once into the system. So if you've got duck the animal and duck the movement, you would have to find the rules would coexist in the cluster, and it would be difficult to find out with the statistics that you and I are most familiar with, trying to figure out the split between those words and their multiple meanings. Plus, it requires a lot of computing. External knowledge, this is an interesting frontier because I think from the taxonomy side or the ontology side, we can bring in a lot of external information, like from an ontology. We know that duck is an animal. We know the other duck is a movement, and we can use that to our benefit. We can have, if we know the content that we're going to use it on is contained to a domain, there's the source we could leverage, and we could pick and choose which Michael Jordan or other ambiguous names would be most likely to arrive in our content about sports versus physics or something. And the benefit will be that you can refine based on the expected text that you're going to see. Another similar idea is gazetteers, which are especially in this case when you might have a long list of companies but don't really see it in your content, you have a list of identifiers for those things. And then beyond that, knowledge bases that are like Wikipedia. What happens if you could take in the first paragraph or two of a Wikipedia article about each company or person or other named entity that you're trying to extract as extra corpus to train on. These are great. They require resources, though. They require manual effort, likely, to create thesaurus, to create a taxonomy, like has been mentioned earlier. It's not an automated process. And when you have new words, you've got to rely that your external system is going to reflect that. And altogether, those models and the ones we've discovered, there's another layer above it. Picking and choosing amongst them and their pros and cons to fit the kind of solution you're interested in and the documents you're trying to use them on. It's just the case that there's no easy recipe for success. One side thing before we move on to a fun little tour through some named entity extractors is, are any other languages than English easier for named entity recognition? I was just having fun with this one. In German, thankfully, or maybe unthankfully, all nouns are capitalized. So picking out a proper noun, apple versus all the rest could be pretty difficult. You also have long compound nouns. I am not a German speaker, so I won't begin to try to pronounce that. But that means the Danube Steamship Company captain, all put together. So you get a big bonus. That means that when you see the long compound noun, you know that each part of that word is the same idea and covers the same thing. But then you have the problem about splitting up this compound noun into its constituent parts and understanding that. In Chinese, there's an interesting, this may be true in Russian, I'm not sure, but there's a special character, a guillemot, or I don't speak French either. So encloses media titles, which I think is a great idea. You know, determining whether or not the commas in English are covering the, are they talking about a quote or are they talking about a work of art? Difficult in English. In Esperanto, every noun ends in O or OJ, so that gives you a leg up for any computing system. It's just too bad we don't have any content in Esperanto. For Chinese, here's a nice example of just one scrape from the internet. You can see the punctuation there in the middle when you translate it into English. This is the title of the musical that they're talking about, and I think that's a great thing for named entity recognition. I doubt it's going to be adopted by folks in English, but we can see. And in this process, I was able to take a quick tour through some named entity recognizers that are present online, publicly facing, or that you have to sign up for with a free account. So this is an excerpt from a New York Times book review. It's got a lot of great stuff for us. It's got some names. It's got a Mexico City Olympics in 1968. In the middle here, they talk about the shoe, the Puma suede, and it's got the name of the book and the author below there. When you send it to one of the more prominent ones, the Stanford Named Entity Tagger, there's a couple here, does a great job with the names. It's picked out everybody perfectly. It's picked out the location of the Olympics. It only tags these three classes below, and we'll see as we go on, there's some other classes that other recognizers are telling you that they'll find. And it's found Black Power as an organization. It's a political movement, certainly, and if your system, you're expecting it to show up as an organization, you might be able to know how to handle that, but if this is for like a business document set, you may not have the same, you may not know what to do with Black Power if it arrives as an organization in your output. This is a 4-class tagger from that Stanford Named Entity Tagger. Now we've got the Olympics, it spotted that. It also thinks that Puma Suede is an organization, and it thinks that Great American Story of Sneakers is an organization. So on the other hand, you'll have to work your way through that. The 7-class one, now we've got Mexico City Olympics, and the date has been pulled out successfully, but we still got the issues with Puma Suede and Black Power. The JSTOR Labs text analyzer, which is something that I've come across as fascinating. I think in this case, though, it's done great with the person's names, but it has Mexico as an organization. I came across a site that had a publicly facing one called Dandelion, and this is what they showed. They had a class for event, and were able to pull out successfully 1968 Mexico City Olympics, and they pulled out Puma without moving on to Puma Suede, so that was pretty great. For Amazon Web Services, their Comprehend tool, they've added title now, and they have also pulled out the 1968 Mexico City Olympics successfully, and they've pulled out the title of the book there successfully. But now they've got Black Power as a title, and on the other hand, when you get the data back, you'll have to figure out if that's expected or unexpected, or if you were able to handle that on the other side. The second phase, of course, is trying to take in this information, and then it's only good with the ability to match it to some kind of core entity in your knowledge base. You can do that by taking in that information that you've got from the recognizer and matching it against the synonyms that you have, or being able to expect maybe some mistakes that come through. And you have to come up with a solution for words with multiple meanings to disambiguate between those. Synonyms examples: for Apple, you'd want to be able to link up any reference that comes through with any of those and any of the products likely. And for other companies, you'd want to be specific about the many variations and maybe possible historical variations of the company so that older documents can arrive to the same, or to be matched to the same value. And you have to have a trustworthy knowledge base. I think we will use some, or we've been familiar with some free knowledge base sites out there in the world, but they're editable by anyone, and therefore you can query them and get back something that you weren't expecting. Classification mistakes: if it sees Alexa the name, but it's actually Alexa the product, have to find ways to work around that. And finally, words having multiple meanings. This is like a common issue for named entity recognition. Once you see that the computer's picked out Michael Jordan, which Michael Jordan are you talking about? Which John Smith are you talking about? If this is Office Space, which Michael Bolton are you talking about? And likewise for geographic locations, which Springfield is this? And like I alluded to before, for companies, Hewlett-Packard is now 2 different entities. What would you do if you came across Hewlett-Packard in text right now? So the questions this brings up is, how can we bridge the gap? How can we bring in maybe information about the context, popularity? Maybe we can do it by domain. What can we see about the relationship between the entity that we found and what's near it? What happens when we get a mention that doesn't have a spot in our database? Do we just allow it in? Or what do we do to handle that? And that's my whirlwind tour of the frontiers of named entity recognition. I think Tom mentioned maybe a question, or I can take some of those at the end. Thanks.